السلام عليكم ورحمة الله وبركاته. ميرو نسرور Chemistry Teacher. Our topic today: pure substances versus mixtures. Matter. It is everything that has mass and volume. It exists in three states: solid, liquids, and gas. Matter divided into pure substances, which divided into elements or compounds, and mixtures, which is divided into homogeneous mixtures as solution, which consists of solute and solvent. Heterogeneous mixtures, which consists of suspensions and colloids, dispersed phase and dispersion medium. Pure substance. It is a substance that made up of only one kind of particles and has a fixed or constant structure. It can't be separated into simpler components without chemical change. Pure substances characteristics. They are mostly homogeneous in nature, containing only one type of atoms or molecules. They mainly have a constant or uniform composition. They have fixed boiling and melting points. They usually enter the chemical reaction to form predictable products. Mixture. It is a substance which contains two or more different substances in any ratio. Its substances don't combine chemically to form a new substance, such as seawater, granite, and gasoline. Mixture characteristics. It is impure substance. They haven't any specific properties. The properties of the mixture are a result of the average properties of all the constituents. They are formed as a result of a physical change. They have a variable composition. They have different melting and boiling points. Homogeneous and heterogeneous mixtures. Homogeneous mixture consists of non-visible particles in a uniform arrangement. Heterogeneous mixture consists of visible particles in a non-uniform arrangement. Homogeneous mixture, it has a uniform composition. It has only one phase. It can't be separated out physically. Homo means the same. Example, alcohol and water. Heterogeneous mixture, it has non-uniform composition. There are two or more phases. It can be separated out physically. Hetero means different. Example, sodium chloride in water. Note: if the solute substance is insoluble, the mixture will be formed. If the solute substance is soluble, the solution will be formed. Solutes can be soluble in some solvents but insoluble in others. Mixtures types. Solution. Their components can't be distinguished by the naked eye or the electron microscope. Example: table salt, cobalt 2 chloride solution. Suspension. Their components can be distinguished by the naked eye. Example: oil in water and mud in water. Colloids. Their component can be distinguished by the electron microscope only. Example: milk and blood. Solutions. It is a homogeneous mixture of two or more substances which are chemically unreacted. Solutions composition. Solute. It is the minor components that has the lesser ratio in the solution. It is the substance that dissolved in a solution. Solvent. It is the major component that has a large ratio in the solution. It is the dissolving medium in a solution. Solutions classification. Solutions can be classified according to the physical state of the solvent, the ability to conduct electricity, the degree of saturation. Solution classification according to solvent physical state, gas solution, liquid solution, and solid solution. Number 2, conducting electricity, electrolyte solution, which is divided into strong electrolyte solution and weak electrolyte solution. Non-electrolyte solution. Number 3, saturation degree. Unsaturated solution, saturated solution, and supersaturated solutions. Solution classification according to the solvent physical state. Gas solution, gas solution, atmospheric air and natural gas. Liquid solutions. As gas liquid solution, soft drinks, oxygen dissolved in water. Liquid solution, as alcohol in water, ethylene glycol in water. Solid liquid solution, sugar or salt in water. Solid solution, gas solid solution, hydrogen gas on platinum or lithium silver amalgam. Liquid solid solution, liquid mercury dissolved in solid silver. Solid solution, as alloys such as nickel chrome alloy. Alloy. It is a solid solutions in which metals or non-metals dissolved in metals. Classification. Solution classification according to the ability to conduct electricity. Electrolyte solution. It is a solution of substances that is ionized or dissociate when dissolving in water. These solutions contain free ions, so they conduct electricity. Example: table salt solution. Non-electrolyte solutions. It is a solution of substances that isn't ionized or dissociate when dissolving in water. These solutions don't contain free ions, so they don't conduct electricity. Example, sugar solution. Electrolytes. They are substances in which their solutions or molten can conduct electricity by the ions movement. They are dissolved in water and ionized into cations, positive charged ions, and anions, negative charged ions. Electrolytes types. Strong electrolytes. They are substances which are completely ionized and strongly conduct electricity. Strong electrolytes ionize completely 100%, in which ions are the principal species in the solution. KCl, high conductivity, because it is a strong electrolyte. Weak electrolytes. They are substances which are partially ionized and weakly conduct electricity. Weak electrolytes ionized partially, usually less than 10%, in which the unionized compounds are the principal species in the solution. Acetic acid solution, low conductivity, because it is a weak electrolyte. Strong electrolyte. Examples: 1. Ionic compounds like sodium chloride NaCl and sodium hydroxide NaOH, which are completely dissociate into ions when they dissolve in water. Number 2. Polar covalent compounds like hydrogen chloride HCl, which is completely ionized when it dissolves in water. Weak electrolytes. Example: 1. Ionic compounds like ammonium chloride NH4Cl, which are partially dissociate into ions when they dissolve in water. Number 2. Polar covalent compounds like acetic acid CH4COOH, which is partially ionized when it dissolves in water. Non-electrolytes. They are substances in which their solution or molten can't conduct electricity, as they have no free ions or hydrated ions. As example, sugar solution and ethyl alcohol. Solution classification according to the type of saturation. Unsaturated solutions. It is a solution which contains less amount of solute and can accept more amount of solute at certain temperature. Saturated solution. It is a solution which contains the maximum amount of solute at certain temperature. Supersaturated solution. It is a solution which accepts more amount of solute after reaching the saturated state by rising temperature. Unsaturated solution. It is a solution which the solute completely dissolves, leaving no remaining substance. Saturated solution. A solution with solute that dissolves until it is unable to dissolve anymore, leaving the undissolved substance at the bottom. Supersaturated solution. A solution with more solute than the saturated solution, that contain more undissolved solute than the saturated solution because of its tendency to crystallize and precipitate. Factors affecting saturation. Temperature. Solubility increases with temperature. pressure. Increasing pressure can force more solute into solution. Chemical composition. The nature of the solute and solvent and the presence of other chemicals in a solution affects solubility. Grinding. Solubility increases with grinding the solid solute. The solution properties. A solution is homogeneous in nature. The solute particle in a solution easily passes through a filter paper. The solute particle in a solution can't be seen by naked eye. The properties of solute are retained in the true solution. Thus, a sugar solution is sweet in taste, and a solution of salt in water is saline in taste. A true solution does not scattering light, and hence does not show Tyndall effect. In other words, solutions are transparent to light. The solute particle in a solution don't settle on keeping. The diameter of solute particle in a solution is about 10 power negative 9 meter. Suspensions. It is a heterogeneous mixture in which the diameter of its particles is larger than 1000 nanometer and can be distinguished by the naked eye. It is a heterogeneous mixture in which the small particles of a solid are spread throughout a liquid without dissolving in it. Example: chalk water mixture, muddy water, milk of magnesia, sand particles suspended in water, and flour in water. Suspensions contains fine solid or liquid particles in a fluid that will settle out spontaneously. By shaking the container, they will again be dispersed throughout. So, suspension is unstable. Properties of suspensions. Suspensions are homogeneous mixture with particles that have diameter greater than 1000 nanometer. The solute particle of suspension can be separated by filtration. The particles of suspension can be seen with naked eye or with the help of a simple microscope. The particles of suspension settle down if it is left without shaking for short time, so a suspension is unstable. A suspension is not transparent to light. Colloid. It is a heterogeneous mixture in which the diameter of its dispersed particles range between 1 to 1000 nanometer and can be distinguished by the electron microscope. The size of solute particles in a colloids is bigger than that of true solution, but smaller than those of a suspensions. Colloids examples: fog, smoke, sprays, dust in the air, milk, mayonnaise, pigment plastic, and toothpaste. Properties of colloid. The diameter of colloid particles between 1 nano and 1000 nanometer. The particles in a colloid are small enough to be suspended throughout the solvent by the constant movement of the surrounding molecules. The colloidal particles make up the dispersed phase, and water is the dispersing medium. Have properties of both solution and suspensions. Particles in a colloid are much smaller than particles in a suspension. Colloids have the same definition as suspension in that a colloid is a mixture in which particles of material are dispersed throughout a liquid or gas. But the particles of a colloid are not large enough to settle out. Particles in a colloid scatter light. Dispersed system consists of particulate matter, dispersed phase, distributed throughout a continuous phase, dispersion medium. Dispersed system consists of dispersed phase and dispersion medium. Tyndall Effect. It is the scattering of light beam as it passes through a colloid, so it distinguishes a colloid from a solution. The particles in a colloid will scatter light, making the beam visible. Types of colloid. At the end, thank you and goodbye.